So this video is going to take us through a couple skills that we learned back in Algebra 1. Be a nice review of that. And it'll also introduce a new idea, but we're going to be talking about graphing something called a relation and finding something new, which you wouldn't have done before, which is the inverse. So a relation is just basically, it's a way of talking about a set of points with inputs and outputs, which we'll get into later in the year. But for right now, look over here at the left, and we have a table with 4 points in it. We have our x value and our y value. First thing we're going to do is graph this green table right here, which is called a relation, which essentially means plotting our x's and y's. So if you remember back, this first guy right here, 2 and then 1, is the same thing as 2 comma 1, where your first number controls your left-right movement. That's your x coordinate. And your second number over here, the y coordinate, controls your up and down movements. So based on that point, like the two numbers we have in our point, we can tell which way our point's going to go. X value of 2 over here means we're going to go 2 to the right. Right is the positive direction. 1 up. That point, 2 comma 1, is right there. Next up, we have negative 3. So we're going to go 3 in the left direction, which is the negative direction for x. And 4 up. 5 comma negative 2. We go 1, 2, 3, 4, 5. And then down 2. Negative y. And then our last point right here is 11 over 4 comma 0. Now, 11 over 4 is not obviously going to be a whole number answer. It's tough to say exactly what that's going to be, but I can take my calculator or however and just get the answer to this. And I can find out that this is about 2.75. It's exactly 2.75. So 2.75 comma 0. So I got 2 right there. If I went all the way to this line, I'd be at 3 on the x. 2.75 is like 3/4 of the way there. So I'm going to just kind of eyeball it. It's halfway between 0.5 and all the way there. So this point would be essentially right where I put it. Go past the 2, 2.75 is about right there, a little before we get to 3. So these are our 4 points graphed on the coordinate plane. And that part is something that we've done before. You've seen that in your previous classes. The second part of this, though, is the part that I want to worry about, which is the inverse. That's the second part of my instruction. So I'm going to erase this to give myself a little room here. Leave the previous points, though. We're going to put it all on one graph together in a sec. So, I'm going to go ahead and find the inverse of this green table right here. And in your previous math classes, you probably haven't done this. We'll do this in more detail later in the year, and it'll make more sense why we're doing it. But for right now, it's like an introduction. Just, hey, here's what an inverse is. More for the sake of getting used to these videos than anything else. To find the inverse, all we're going to do is switch our x and y coordinates. So switch the x's and y's. So my original point right here was 2 comma 1. What I'm going to do is take those two coordinates and flip them around. On my inverse, the point's going to be 1 comma 2. Here I had the negative 3 comma 4. Well, I'm going to flip that over. It's going to be 4 negative 3 on my inverse. Negative 2 comma 5 for this next one, and finally 0 comma 11 over 4. All you're doing is trading your x and y. And then I'm going to go and quickly graph my new points. 1 comma 2 would be right here, using the different colors to keep these straight. 4, let's see, 1, 2, 3, 4, negative 3 would be right there. Negative 2 comma 1, 2, 3, 4, 5, and finally 0, 11 over 4. So that would be my new relation right there. I have the inverse of my original green guy. So I'm going to put up a second example here, and I'm going to cover up my work and everything. I already worked this one out. I want you guys to actually pause the video and try doing this problem for yourself in just a second here. See if you can figure out what's going on based on what you saw in the last example. So, same instructions as before. I want you guys to take that green table right there and do a couple things. First of all, I want you to figure out what the go ahead and graph that original. Then I want you to figure out what the inverse is and graph that as well. Pause the video right now because I'm going to pull up the answer here so you guys can see if you got it right. So this is what our inverse is. Again, all I'm doing is trading my x's and y's, flipping them around. I graph them both. Now, some of you guys at this point may have seen kind of a neat pattern with our points of the original and the inverse. I'm going to go ahead and draw in a diagonal line right here. Just like this. Little crooked there at the end. But if I draw my diagonal line like this, this is actually the line y equals x, which again we'll get into later in the year, but If you remember from your Algebra 1 days, that's how you write the equation of a line, that line right there. Notice, if I tilt my picture right here, it's the same thing on both sides of this line. The green side and the red side, the regular and its inverse, are symmetric around that line. That's actually worth noting. So they're symmetric about the line y equals x. So there's symmetry going on there. I'm going to pull up my last example to kind of close this video off and show you that on that one it works as well. This was my function the first time around, and I've got some points on either side, but I'll draw in that blue line again so you can see what's going on here. If I draw in that line y equals x, notice it's like a mirror image on both sides of this line. So that's the basic idea of having an inverse. You notice those two sides right there are the same.